Assalamualaikum warahmatullahi wabarakatuh. Introduce myself, I'm Budita Luciana, and I would like to explain about visible basis solution. Well, I will try my best to explain this chapter, so let's begin. Okay, for discuss this chapter, first of all, we have to know and understand what is canonic form. Okay, I already written all of specific of canonic form. So first, all decision variables are constrained to be non-negative. And second, all constraints except for the non-negativity of decision variables are stated as qualities. So if we have some constraints, for example, rules, if it's greater than 0, it's not a problem. The other constraint must be 0. And the right hand side coefficients are all non-negative. So if we have equation, the coefficient of the variables must be non-negative. And the last one is one decision variable is isolated in each constraint. So what is the isolated itself? We will see in next slide. Okay, so this example, we see this example is not already variable standard for canonic form because still inequality. So if we want to change this variable, we change it become equal, but if it become equal, we need another variable that called slack. For example, if there's no slack, okay, so this is 1 plus 5.1 becomes 6. It fits in this problem, in this symbol, sorry. But it's not fit in this symbol because 1 plus 5.1 becomes 6 is equal than 11. It's not same. So we need to add variable called variable slack to complete the equation. So for example, this 1 plus 5.1 becomes 6, and we know what the amount of the x3. So we know the x3 is 5, so 6 plus 5 equal to 11. So the right and the left side have same value. Okay, same as like the second equation, but what makes different? The symbol is greater. Okay, so the variable slack will be minus, but both of the variable slack is greater than 0, is for greater than 0. Okay, next, there is another example or another form like this: x1 plus x5 equal to 20 with x1 greater equal to 0 and x5 in unrestricted. So that means that x5 can have whether minus or positive value, but in canonic form all of equation must be greater than 0. So x is x1 greater than 0 and so on. So we need to change x5 become x6 minus x7 because x5 is unrestricted. So x5 change with this equation, the new equation. So it become like x1 plus x6 minus x7 equal this constraint. With the term x1 greater than 0, x6 also, and x7 greater than 0. Okay, next slide. So this slide is talking about how to solve equation linear. So for this example, we have two rules. How to process. We have this condition: line 1 is reduced by line 2. So the line 1 is reduced by line 2, so it becomes 2 minus 1 become 1. 1 minus 1 minus 1 becomes 0, 1 minus 0 becomes 1, and 1 minus 1 becomes 0, and 5 minus 3 becomes 2. So this is the result of the process of the first process. Okay, how to change this of line 2? So we can change line 2 with line 2 is reduced by line 1. So the line 2 become like this, from 1.1 becomes 0, 1.0 become 1, 0 minus 1 become minus 1, and 1 minus 0 become 1, and 3 minus 2 become 1. So this all of the process called pivot operation. Okay, so next slide. We'll see the conclusion of the process I mentioned before. So system S1, S2, and S3, namely equivalent. It is solution for one system but automatically gives the solution to the other system. So this system is connect each other because the process itself with the equation equation. Okay. And second, for system S3, x3 and x4 equal to 0. So x1 become 2 and x2 become 1. So if we enter the 0 into the x3 and x4, so x1 have value equal to 2 and x2 equal to 1. And system S3, call it canonical system. Why? Because the x3 is not isolated. X3 have like kind of friends in another equation, and x1 and x2 is isolated or called basis variable because they haven't friends. I just called it friends. So x1 and x2 is not another like couple, and x4 also. But yeah, we just focus on x1 and x2. Okay, next slide. Now we try another example like this. This is z equal. We have a proposed function. This is z equal to x1 plus 8 and x2. Limited functions such follow: x1 lower equal to 2, x1 plus x2 lower equal to 3, x1 x2 greater equal to 0. Okay, first step, we change this equation become canonical form like we do before. So this first equation we add with x3 as a variable slack in the red part, and then in the second equation we add the x4 as variable slack also. Okay, x1 x3 equal to 2, x1 plus x2 plus x4 equal to 3, and all of the condition it must be greater than 0. Okay, so we transform or we change the form become with matrix. Okay, we have a1, a2, a3, a4. It means that this is a1, a2, a3, and a4. So we need to write the coefficient become matrix. For example, the a1, you can see the coefficient is 1, this is 1, so we write this is 1, this is 1, 0 1 0 1 1 0 0 0 1 0. Okay, so what is feasible basis solution? So you can read, this is the general definition of feasible basis solution. So it means that we make isolated variables such as same value equal to right side equation and make the other variables 0. So if we see this standard form, we can already know we already know where is basis and where is the non-basis, so we can know this is basis. X3 and X4 become, yeah, I think I make mistake. This is x3 equal 2 and this is x4 equal 3, and the non-basis is x1 equals 0 and x2 equal to 0. So the one who is isolated it's called basis, but the one is not isolated is called non-basis. But x2 it also isolated, but we cannot we cannot do that because x2 will be joined to the x1, so x1 and x2 will become non-basis, and x3 and x4 become basis. So we have to try this canonic form. So this matrix will be processed in this formula. So let's see the first trial. Oh, okay, this is B. B means the matrix itself. So we have matrix A is not problem. We can transform it into the matrix B. So B equal A1 and A2. What is A1 and A2? A1 and A2 is this row. I mean this column. Okay, 1 1 0 1 1 1 0 1 times x1 and x2, because this is a1 and a2. A1 from coefficient x1 and then a2 is coefficient from x2 equal with the constraint. Okay, so after we do this, we inverse the matrix. So the inverse will be x1 and x2 equal 1 1 0 1 times 2 3. We inverse it. So we need, the formula of inverse itself. It is 1 per determinant point 1 per determinant times adjoint. So you can switch this diagonal and then we can times into the minus. This become minus 1 and 0. So we just calculate. So 1 per 1 equal to 1. So we just times to the matrix. 1.1 is 1, 1.0 is 0, 1.1 is minus 1, 1.1 is 1. So the result, this is called B. The result, it will transform into the formula xb. So xb equal x1 to x2 equal b inverse point B equal to this result times b. B means the constraint of the equation, which is 2 and 3. And we have result, this is 2 and 1. So from this result, we know the basis of x1 is 2 and x2 is 1. So the rest is non-basis because we already get the basis from x1 and x2. Okay, but how about the others? How about the x1 with x3? So we'll see. Just try with the same way. We can know the a1 is a3 is 1 1 and 1 0. Okay, and x1 and x3 equal to 2 3, and then we inverse it. So we got 0 1 and 1 minus 1. So we can times it and we have result. Okay, so we have okay, there is a mistake. It has 2 times with constant, but the result is yeah, it's true. This is the value of basis x1, so and this is the value of x3. So we get another basis, another value of basis. This is x1 equal to 3, x3 equal to -1, and the rest is non-basis, 0, 0. How about the other? So well, we'll see about A1 and A4, which is 1, 1 and 0, 1. Okay, we calculate again, and we got basis x1 equal to 2 and x4 equal to 1, and the rest is non-basis. Okay, we try again, find it again, x2 and x3 in order new basis, and then there is a no inverse in here because the adjoint is cannot calculate. So how about this one? This one is basis solution which is not feasible. So this so the A2 and A4 cannot calculate, cannot become like the others because this is not feasible. Okay, try another one. So this is the last A3 and A4, which is I10 and 01. And then we got the new basis of the sixth trial, and the conclusion is x3 equal to x4 equal to 3, and the rest is non-basis. Okay, so we can recapitulation all of that we got, all of the conclusion. You can know who is the variable basis and who is the variable non-basis. We just add it in the table, and we can get the z value. So in z value, we just focus on the x1 and x2. Okay, if the z acts to maximum, we can use this one. Okay, you can use the 24. Yeah, this will be the maximum value of z. This point. Okay. How about we see in the graphic? So the graphic will be like this. This is x1 lower equal to 2. This is just go straight, the graphic just goes straight. Then x plus x1 plus x2 lower equal to 3. Here become like this. The graphic become like this. And the shaded area become in here because this is the lower. Okay, you can see the symbol is the lower goal. So this is the shaded area. Again, we can edit all of the point of this. Yeah, this is point 1, 2, point 1, 2, and 1, and second 3 and 0, and third 2 and 0, fourth 2 and 0 and 3, and the last is 0 and 0. Okay, this is x1. Oh, sorry, this is x1, this is x2. Okay, so yeah, that's all for me. I'm really sorry if there's any mistakes. Wassalamualaikum warahmatullahi wabarakatuh.